Look up at the question on the blackboard. He says there's an object AB placed at twice the focal length of the convex lens, and then a flat mirror on the other side at 3 times the focal length, placing another flat mirror, asking how many images this object can form in this optical setup, how many images can be formed. In our last session, we discussed what an image is. An image is the focal point of all refracted light rays. So if countless light rays from point A hit the convex lens, all their refracted rays should converge at the image point, regardless of these 3 special rays, parallel to the main optical axis passing through the core or focal point. They all eventually converge at this image point. Actually, for many ordinary light rays, for example, if I draw a random one, look at this yellow light ray, where should it also converge? At the image point makes sense, right? Let's connect the image point to trace it out. So once we find the image point, we know how all light rays directed at the convex lens will refract and travel. Understand? But this problem has a flat mirror, meaning all refracted light converging at the focal point will continue traveling. Watch this process. See? It continues to the flat mirror. After hitting the mirror, look for some light rays. I'll draw their normal lines. Using the law of reflection, we can find what? Their image in the flat mirror. See? Some reflected rays when extended backward focus at a point behind the flat mirror. This point is actually the second image formed through this optical setup. Let's call this S2 and this S1. Some light rays, after hitting the mirror after reflection, continue toward the convex lens. Though they form an image in the mirror, their reflected rays continue to the convex lens. After passing through the lens again, if they converge at a focal point, won't that create another image? So we can find how this third image forms. Look at this ray hitting the flat mirror. Finally, it's reflected back by the flat mirror and shoots out along the original direction. The light path is reversible. You see, this ray of light, the incident ray, becomes what? Doesn't it become the reflected ray that continues to travel? Can you understand this? Good, let's continue. Now look at this yellow ray. After it hits the plane mirror, it will also have a reflected ray, right? Which direction does the reflected ray go? It forms a focal point with this ray. Look here, this becomes the third image called S3. So to summarize, of course, you can draw more diagrams yourself. Draw it several times and you'll discover these 3 images. S1 is upright, S2 is inverted and equal in size. And finally look at S3.